Good day, students. We're here once again to study physics. And our topic of today is equilibrium of bodies in liquids. Equilibrium of bodies in liquids. Specific objective. At the end of the lesson, you should be able to state the Archimedes principle. Describe an experiment to verify the principle. Solve questions based on the principle. Now state the principle of flotation and list the applications of flotation. Okay. Equilibrium of bodies in liquid. So we say that when a heavy object is partially or completely immersed in water, so common experience shows that the object appears lighter than it was in air. So this is experienced when a bucket of water is being drawn out from a well. So the bucket appears very light when it is still underwater, that one can easily draw it out with one hand. But as soon as it is out of water, it becomes very heavy, and one has to use two hands to draw it out. So this is everyday experience which we all know. And this is a puzzle. So this puzzle was first explained by a Greek scientist, the Archimedes. So you look at this man drawing water from a well. So because the bucket is still in the water, he could draw it very easily without any effort. Okay, so now we look at the Archimedes principle. So Archimedes shows that while in water, so while the bucket was in water, it experiences an upward force on its body. So, and this force is called the upthrust of the water on the body. So that is what the upward force is called. So now he said that if the upthrust is denoted by U, then the resultant force experienced with the tension within the tension of in the rope, okay, which the tension of in the rope when the object is underwater is given by T is equal to W minus U, where T is the tension, W is the weight of the object when it is out of water, and U is the upthrust. Then upthrust can then be written as the upthrust is equal to weight minus tension, which is equal to loss in weight. So whenever an object is in water, the loss in weight is equal to the upthrust, which is equal to the weight minus tension. Okay, now we go to the Archimedes principle. The Archimedes principle states that when a body is partially or totally immersed in a fluid, fluid is liquid or gas, it experiences an upthrust which is equal to the weight of fluid displaced. So here we use the word fluid because it happens in both liquid and gas. So the Archimedes principle is applicable to both liquid and gas. So once again, Archimedes principle states that when a body is partially or totally immersed in a fluid, it experiences an upthrust which is equal to the weight of the fluid displaced. Okay, now let us verify the principle. Verification of Archimedes principle. So we verify it using a simple experiment. The aim of our experiment is to demonstrate Archimedes principle. Then the procedure. So we pour water into an overflow can. An overflow can is also called a eureka can. You pour water into a eureka can until it starts to flow out. Then you wait until it stops dropping. So you are going to start when the liquid has stopped or the water has stopped dropping. Then the step 2, you tie a suitable solid body securely. Such body can be a stone, just any solid object you know that cannot melt, that cannot dissolve in water. You tie it securely and suspend it on a spring balance. So when you suspend it, the spring balance will record the weight. So you now determine the weight when it is in A. Then step 3, you lower the body slowly into the overflow can while still attached to the spring balance. Then you read off its weight when it is fully submerged. So what you do, look at the diagram. The diagram shows the first step when the body is suspended in a spring balance and it is in A, you record its weight. Now the second diagram shows when the body is now completely immersed in the water. You know, when as soon as it is completely immersed, you discover that it will displace some water, and those water will pour out. So when they pour out, they will now be collected through this container. Now, when it is collected, the next step is that you weigh that water that is collected in the beaker. You weigh it and you record your reading. Okay, now let's consider the following readings as the readings obtained from the experiment. Now we say let the weight of the body in A be W1, then the weight of the body in water be W2, then weight of the empty beaker be W3, then the weight of the beaker and displaced water be W4. So we now see here that the upthrust of the body is going to be weight in A minus weight in water. So this upthrust is equal to the what? The weight is the loss in weight when it is inside water. Now the weight of the water displaced is equal to W4 minus W3. Sorry, is W4 minus W3. So we now see that if we check, we discover that W1 minus W2 will be equal to W4 minus W3. And that verifies Archimedes principle. That shows that the upthrust is equal to the weight of the water displaced. So okay, now we'll go to example. Let us solve questions based on this Archimedes principle. Example number 1. A solid weighs 90 Newton in A and 20 Newton in a liquid of density 700 kg per meter cube. Then you are to calculate the question A, upthrust of the liquid on the solid. B, the volume of the solid. Okay, solution. Remember we say upthrust is equal to loss of weight. You see the solid, the same solid that weighs 90 Newton in A, when it is in the liquid, it weighs 20 Newton. So now what is the loss in weight? So the loss in weight we are going to see is W1 minus W2. While W1 is the weight in air, W2 is the weight in water. So 90 minus 20 gives us 70 Newton. So that means that particular solid lost 70 Newton of weight when it is inside the water, and that is the upthrust. Okay, since now we go to question B. Now, since the loss in weight is 70 Newton, therefore that loss in weight is equal to the weight of the liquid displaced according to the Archimedes principle. It says the upthrust is equal to the weight of liquid displaced. So here the weight of liquid displaced is 70 Newton. So if we convert the weight to mass, we now see that the mass of the liquid displaced will be 7 kilogram. Since we know that mass is equal to weight divided by acceleration, so that due to gravity, that 70 divided by 10 gives us 7 kilogram. Okay, so it means the 7 kilogram of water is what is, or of the liquid is what is displaced. Okay, now we look at the volume of liquid displaced. We now say the volume of liquid displaced will be equal to mass of liquid displaced divided by the density of the liquid, which is 7 divided by 700, which we get to be 0.01 meter cube. So that is the same thing as 10,000 centimeter cube. That is the volume of liquid displaced. Now here, you know that since that solid is completely immersed, the volume of the liquid displaced is equal to the volume of the solid. Therefore, the volume of the solid is 0.01 meter cube, which is equal to 10,000 centimeter cube. Okay, now example number 2. Example number 2, we say an object of mass 60 gram and density 10 gram per centimeter cube is suspended in a spring balance and lowered until half of its volume is immersed in a liquid of density 0.80 gram per centimeter cube. Now you are told to calculate the tension in the string. Calculate the tension in the string. So here, the object is partially immersed in the liquid. It's not completely. They say it is lower until half of its volume. So what we need to do is we are going to find the volume that is submerged. Okay, let's first of all find the volume of the object. We know that volume is equal to mass over density, where the mass is 60 and density is 10. So 60 divided by 10, you get 6 centimeter cube. So now, so far half of the volume is immersed, therefore the volume immersed is going to be 3, half of 6, which is 3 centimeter cube. Okay, now the mass of the liquid displaced, you know that it means that the volume of the solid will be the same thing as the volume of the solid submerged is equal to the volume of the liquid displaced. So that means the mass of the liquid displaced will be the same thing as the mass displaced by 3 centimeter cube of the liquid, which is the density of the liquid multiplied by the volume displaced, which is 0.8 multiplied by 3, we get it to be 2.40 gram, which will now give us 0.0024 kilogram. That is the mass of liquid displaced. Therefore, the upthrust is equal to the weight of liquid displaced, which is 0.0024 kilogram multiplied by 10, giving us 0.024 Newton. Okay, from the Archimedes principle, we see that tension is equal to weight minus upthrust. So you know the weight of the object is 0.6, while the upthrust is 0.024. That means the tension is going to be 0.6 minus 0.024, giving us 0.58 Newton. So, and that is the tension in the string. Okay, now we move over to flotation. Flotation. We said that if a body is denser than a liquid it is placed, it sinks. It sinks in it completely. For instance, you bring iron, which is much denser than water, you put it inside water, the iron will sink completely in water. Now, but when a body with density less than that of a liquid is placed in it, the object will sink, but not completely. It will sink until the weight of the liquid displaced by the submerged volume is equal to its own weight. It will then float, and the body is in equilibrium. So consider an empty gallon. So when you place empty gallon in water, you find out that the gallon will just displace small quantity of water, but it will float. You know, it will not just float on top, it will sink small. Some people will think that the empty gallon will not sink at all. It will. If you want to check whether it will sink, now fill a can with water, or let's say a container with water, then drop the empty gallon. Immediately you drop the empty gallon, some quantity of water will pour out, showing that the gallon has displaced some water. That tells you that it will sink. So, but it will not sink much, to just sink a little until because and displace small quantity of water. That small quantity is telling you that the weight of gallon is also small, because at equilibrium position, the weight of the water displaced is equal to the weight of the gallon. Okay, we now say, given that the upthrust is U and the weight of the object in A is W, then for an object to float, the upthrust must be equal to its own weight. So we write it, the weight is equal to the upthrust. So this is what we call the principle of flotation. So now the principle of flotation states that an object floats in a liquid when the upthrust exerted upon it by the fluid it will float is equal to its own weight. Again, it is stated that an object floats in a fluid when the upthrust exerted upon it by the fluid is equal to its own weight. Remember, the upthrust is that upward force. So if that upward force is equal to the weight of that object, the object will float in that fluid. Okay, alternatively, we can state it that a floating object displaces its own weight of fluid in which it floats. So what this second definition is telling us is that any floating object displaces the fluid which is equal to its own weight. What does it mean? Like I said earlier, if you want to verify this principle of flotation, you can bring a floating object, for instance something like an empty gallon. You now suspend the gallon in air in a spring balance and suspend it and check the weight, record the weight. Now you now fill a container with water. Now put the empty gallon inside the water, and you discover that some water will pour out. You collect that water that is poured out, you weigh the water. When you weigh the water, you discover the weight of that water must be equal to the weight of that empty gallon. That tells you that the water displaces its own weight in the fluid in which it floats. That is what we call the principle of flotation. Okay, now let us discuss the factors affecting the flotation. Number one, density of the body affects the flotation. We say that a body will float in a fluid if its density is less than that of the fluid. That is one condition. If the density of that object is less than the density of the fluid, it will float. Then, number two, the shape of the body. For the first condition, it is density. This one is the shape. Now, we discover that under this shape, a body can float in a liquid in which the density is bigger. We say that if the density of a body is less than that of a liquid, but there are some cases whereby the density of a body will be greater than that of liquid, but still the object can float in the liquid, depending on the shape. Some objects has a shape such that they can displace large fluid whose weight equal to its own weight. So it is on this note that we know that ship can float in water, even though ship is made of steel, different steel, high carbon steel. These steels are very heavy, heavier than water, but ship can float in water. Why? Because ship is designed in such a way, it has a hollow shape in such a way that when it is in water, it displays a large quantity of water, and that water, the weight of that water will now become equal to the weight of the ship. Also, on this, that we see that balloon can float in air. Why? Balloon is supposed not to float in air. It's supposed to rise up in the air because it is filled with a lighter gas. These gas are usually what? Lighter than air. It's supposed to rise continuously, but we see that sometimes it will float because of what? The shape of the material used in making the balloon. So when it tends to rise up, the weight of the air it will displace will now become equal to its own weight. Therefore, it will remain floating. Okay. Then you look at the ship, the ship, the hollow shape of the ship, making the upthrust on the ship to be so great so that it can support the weight of the ship in the water. Okay, let's look at some of the applications of flotation. Number one, we talk about ship flotation. We said the principle of flotation explain why ship made of steel or boats do not sink to the bottom of the sea. As the ship is lowered until it is lowered into the water, then it is sinks until it displays a quantity of water whose weight is equal to its own weight. Then it begins to float because the upthrust of the water on the ship now equal to the weight of the ship. That is, you will find out if you have gone to see, if you have seen a ship, you find out that when ship approaches a harbor, you see that the height of the ship continue to grow. Why? Because it's telling you that the portion that is submerged in water is also great. It need to go down so that it displace a large quantity of water. Then number two, there is what we call the Plimsoll Line. Plimsoll Line. So this Plimsoll Line is a set of lines on a ship. Every ship has this set of line, and these lines show the level with which the ship can safely and legally be loaded under different conditions without any damage of the ship sinking completely in water. Anytime you see a ship, go close to it, see the middle side, you see a set of lines drawn there. They are called the Plimsoll Line. So at any given time, at a particular season, they will load. As they are loading the ship, they will be watching, because when the ship is being loaded, you know, the ship will be going down, it will be sinking into the water, it will be sinking. So when it gets to the minimum, the required Plimsoll line for that particular season, and for the type of water the ship is to sail through, then they will stop loading. Any further loading beyond that line, then the ship have the possibility of sinking. So now we know that, firstly, we should know that salt water of the sea and fresh water, they have different density. So because of that, we say that ships sink more in fresh water than in sea water. Why? Because the sea water is denser than fresh water. So when the ship is to pass through the sea water, then the Plimsoll line must be above. But when it is in the fresh water, the Plimsoll line must be below. Okay, so we also say that the density of winter seawater is greater than the density of summer seawater. So you see that season also affects. So that's why if you look at the Plimsoll line we have here, look at the Plimsoll line in the ship. See the two sides, these two ships, we have the Plimsoll line, the level, we see F, T, B, and W. So those level indicate different level we need to load the ship at different types of water and season. So you see LR means the left and right. In this case now, you see that the ship is just at its normal level. So when it is between this, at this level B, it means it has not been loaded. So when we load it, then we now, you see that it will begin to go down, it will begin to go down, approaching the level T or F. Then this TF is the maximum level we can load the ship in any condition. And it must be during winter for us to, before we can load the ship up to that level, because of what? The density of the seawater. Okay, now number three application, we'll talk about submarines. Submarines are used by naval forces. So the submarines can be made to completely submerge in this manner it will travel through deep water of the sea. So you see that submarine will sink into the water and move through the deep sea. Then it can also be made to rise to the surface of the water when it is desired, and thus it is sails on open water. So if a submarine want to move above the surface of the water, it comes out. When it want to move below, it sinks. Now, what are the principles? We say that this submarine sink by taking water into a large tank. A submarine has a large tank in its body. That large tank is called buoyancy tank. When the submarine want to sink, they begin to pump water into the buoyancy tank. As the buoyancy tank is filling with water, the ship will be sinking until it's completely submerged in water. So now, when the submarine want to rise, what did they do? It has another tank that contains compressed air. That compressed air is open to the buoyancy tank in such a way that it will use a very great force and blow out water from that buoyancy tank. So when it blows that water out, then as the water is going out, then the submarine becomes lighter. And as it is getting lighter, then the upthrust of the water will be pushing it out, making the submarine to come out until it floats completely on the surface of the water. Then number 4, we talk about balloon. We say a toy balloon floats in air if it displaces a volume of air which has weight equal to that of the balloon fabric and the gas filling it. So that is the condition that will make the balloon to float. We say that sometimes a lighter gas such as helium, helium is 14 times less dense than air. So sometimes we use helium inside the balloon. So when we use it, we now find out that the total weight of the balloon is now becoming much less than the weight of the air it displaces. So at this point, the balloon will rise in the air. It will no longer float. Then number 5, we look at the hot air balloon. We have another one called hot air balloon. Now, in the hot air balloon, air is heated by a burner underneath the balloon to a temperature at which it is much less dense than air outside. So if you see a hot air balloon, you see that the air inside the balloon is heated by the burner. The burner will heat the air. As it is heating the air, we find out that hot air is less dense than the cold air outside. So when it hits the air, it becomes less dense. And as it is getting less dense, then it means that the balloon will become light, and then the air displaced will now become equal to the weight of the balloon. So the hot air balloon can float in the air because of the flotation principle. Then number 6, we look at hydrometer. Hydrometer is another application of flotation. We say hydrometer is an instrument used for measuring the density of a liquid. The construction and operation are based on the fact that the depth to which a tube sinks depends on the density of the liquid in which it is floating. So here we now say the length which the hydrometer sinks is inversely proportional to the density of the liquid it is floating. So the length is inversely proportional to the 1/density. So that means if hydrometer is immersed in a less dense liquid, it is going to sink more. But if it is immersed in a denser liquid, it will sink less. So on that, we use this principle to measure the different densities of liquid. Now, hydrometer play a very important role in our everyday life. We have different types of hydrometers. Then we have the one we call the lactometer. Lactometer is a type of hydrometer used to measure the density of milk. We want to know whether the milk is well concentrated and adulterated or not. So that type of hydrometer is called lactometer. We also have alcoholometer. Alcoholometer is a type of hydrometer used to measure the density of alcohol and wine. These hydrometers are mainly used in quality control. For instance, NAFDAC and Standard Organization of Nigeria, they use this to measure some imported wine to ensure that they meet up with the quality standard. Because you see some wine, they will just write that this wine has this so percentage of this. Meanwhile, in actual measurements, we find out that the density is showing that the active ingredient is less than what is written on it. So that is the function of alcoholometer. Now, we also have another one we called the urinometer. Urinometer is used in the hospital for urine analysis. They use it to measure the concentration of the urine, to especially in diabetic patients and some other patients. So to check if the concentration of the urine increases, then the density will become high. It then means that the person has a problem, because the active ingredient is now passing out through the urine. Then we also have another type of hydrometer we call the thermohydrometer. This thermohydrometer is one of the most important hydrometer that is used. We use it to measure the density of fuel oil, like petrol. We have the one for petrol, we have the one for kerosene. You see that these petroleum product price regulatory agencies, they move about from one filling station to another to check, because some people adulterate their petrol. They use some other liquid to mix with it. So they use this thermohydrometer to check the density of the petrol. The density of petrol is usually less than 0.75 gram per centimeter cube. That of kerosene is between 0.75 to 0.8. So if they get anyone whose density is above 0.75, it means it is purely adulterated, because the adulteration increases the density of the petrol, and when it increases the density, you now find out the rate of combustion will reduce. So it can possibly cause knocking of engine. It can equally cause explosion, especially when it is used, it is mixed with kerosene. So these are some of the types of hydrometers. We also use hydrometer in soil analysis. We also have acidometer, the one used to measure the density of acid. You will also know that the battery chargers, they use hydrometer. The hydrometer they use to measure the relative density of the acid in the battery. Now, this diagram show different types of hydrometer. The first one is lactometer. The second one is alcoholometer. The third one is acidometer. The fourth one is the thermohydrometer, while the fifth one is normal hydrometer. Then this one here is the one used by the battery charger for measuring the relative density of the acid. Okay, in summary, we say that the object experiences a lighter weight when it is in water as a result of, or in any liquid, as a result of the upthrust that is exerted on its body by the liquid. And the Archimedes principle states that when a body is partially or completely immersed in a fluid, the upthrust is equal to the weight of the fluid displaced. Also, the principle of flotation states that a floating object displaces its own weight of fluid in which it floats. That means an object floats in a liquid if the upthrust exerted on the body by the liquid is equal to the weight of that body. We also say that the two factors that affect the flotation are the density of the liquid and the shape of the body. Okay, we also talk about the applications of flotation. We mentioned the ship flotation, we mentioned the Plimsoll Line, we mentioned the balloon, we mentioned the hot air balloon, we also mentioned the hydrometer. We still have various other applications of flotation. Like we have what we call Cartesian diver. We also have the floating of ice barge and so on and so forth. Okay, now here is the assignment. Question number 1, you are to state Archimedes principle. Number 2, describe an experiment to verify Archimedes principle. Then number 3, an object of mass 200 gram and density 25 gram per cm cube is suspended in a spring balance and lower until 3/4 of its volume is immersed in a kerosene of density 0.75 gram per cm cube. Now calculate the tension in the string. The number 4, you say what is a Cartesian diver and explain how it works. So you submit this assignment in Google Classroom. Any question, you also forward it. We are going to discuss them in Google Classroom. Thank you for listening and stay safe.